Hello and welcome to Unit 2, Lesson 4, Ready, Set, Go. So, our ready questions say, factor out the greatest common factor in the expression, then simplify the numbers inside the parentheses. So for our first one here, we see that there's a 7 in both of these terms. So we factor that out. 7, remember when we factor it out, it's like we divide each term by 7. So here we're left with 1 plus 0.675. Or, if I simplify inside the parentheses, 1.675. Okay, our next one we see that they both have a factor of 19. Just like the last time, it leaves us with 1 plus 0.33. So 19 times 1.33. Here, 38 is in both terms, so let's factor that out. We have a subtraction, so 1 minus 0.42. So that gives us 38 times, 1 minus gives us 0.58. Okay, and lastly we have 67 as our greatest common factor. So leaves us with 1 minus 0.92. Well, 1 minus 0.92 is 0.08. So 67 times 0.08. So there's question 1. Question 2 says, Jackson has invested $500 in an excellent money market account that earns 20% interest per year. Given is a chart of his year-end balances that appeared on his investment statements. Jackson's money is growing exponentially, and he recalls from a previous math class that the formula for an exponential function is y equals ab to the x. He recalls that a is 500, right? That's that initial value or beginning balance. Initial value. And x is the number of years. He thinks b should equal 20% or 0.2, but that number isn't giving him the numbers on his bank statement. What number should he be using for b? Explain. So his account earns 20% per year. So it's 20% in addition to his original 100% investment. So really he's actually in the account is this 120% of his beginning balance. And I'll call it previous balance. So, percent, remember, percent means out of 100. So, B is that 120% out of 100. So, 1.2. So, B should be 1.2. Okay. Let's go on to question 3. Jackie owes $500 on a loan. She has agreed to pay the loan company 8% of the outstanding balance of the first day of each month. Given is a chart of the balances she owes after each payment. Jackie knows her loan balance is decreasing exponentially. She also recalls from previous math class that the formula for an exponential function equals y equals ab to the x. She replaces a with 500 and lets x be the number of monthly payments. So our time here is in months, not years. So that's good to note. When she uses 8% or 0.8 in the formula for B, it doesn't give her the correct balance for each month. What should she be using for B? Explain. Well, she's paying, so it's 100% originally, right? And she pays 8% each month. So that means that 92% remains. So of the previous balance. Whatever balance came before it. So that's the value we want to use to find B. B is 92 out of 100, or really, B equals 0.92. Okay, question 4, So we're going to move on to the set problem. So question 4 is a logarithm. So the directions say use properties of logarithms to rewrite the indicated logarithms in terms of the given values. Then find the indicated logarithm using the given approximate values. So let's review our properties. We have the product property. So product, when we see a product inside a logarithm, we can separate those logs as two individual logs being added together. Right? These rules are very closely related to our exponent rules. If I have two terms in exponent being added, I can actually do their bases, or them as two separate bases being multiplied. Same things with quotient. If I have x to the m, x to the m divided by x to the n, I actually subtract those exponents, right? M minus n. Well, we see that with this quotient of log of a over b becomes log of a minus log of b. So quotient. And then our last one, our power. Right? If I have log of a to the c, I can write that as a coefficient of the logarithm. Right? That power in the logarithm becomes something that's multiplied in front of the logarithm, or coefficient of the logarithm. So those are those property rules that it's referring to. So it gives us a few givens. Log of 16 is 1.2, log of 5 is 0.7, and log of 8 is 0.9. So basically, we want to try to only use those numbers to create our logarithms. Now, we're not given these, but we also know powers of 10, right? Log of 10, for instance, well, we want to think 10 to what power equals 10? Well, that's just 1. Log of 100, well, we want to think 10 to what power equals 100? That's 2. So we also know powers of 10, right? So we don't need them for this first one, but they might come in handy for some of these. So let's rewrite log of 5 over 8. So I can write that as log of 5 minus log of 8. Well, the problem tells us that log of 5 is approximately 0.7, and log of 8 is approximately 0.9. And notice the directions say, do not use a calculator. So we're going to do all of this sort of mental math. The difference between 0.7 and 0.9 is 0.2, and since the larger number is negative, it's going to be negative 0.2. Log of 25. So 25, we can think of this two ways. We can think of it as 5 times 5. So I'll do that first, right? So log of 5 times 5. Well, that becomes log of 5 plus log of 5. Well, log of 5 plus log of 5 is 0.7 plus 0.7. 7 plus 7 is 14, right? So 0.7 plus 0.7 is 1.4. We could also have thought of it as 25 is 5 squared. We could have used the power rule. So this could have become log of 5 squared, which could become 2 times log of 5. And I actually prefer this way. I prefer the multiplication, but it is just a preference. There's not one way that's sort of better than the other. I just like multiplication over addition since it's less to write. So 2 times 0.7 is 1.4. We get the same result. Okay, log of 1/2. So I don't have a 1 or 2 anywhere in here, but I do have an 8 and 16. So log of 1/2 can be the same thing as log of 8 over 16. That's still equivalent to 1/2. Well, I know log of 8 and I know log of 16, right? Those are both given to us. So log of 8 is about 0.9 and log of 16 is about 1.2. So the difference there is 0.3. Again, our larger number is negative. So negative 0.3 is our result. Okay, question 7, 80. So this one's not as obvious to get from 16, 5, and 8. But 8 and 10 hopefully stand out to us pretty quickly. So I'm going to do this as log of 8 times 10. Now, I could break 10 down more and use a 5, but I don't know what log of 2 is, so it doesn't make sense to do that. I'm going to keep it as log of 10 because I know what log of 10 is. So I can make this log of 8 plus log 10. So even though, let's say log 8 is 0.9. So even though log of 10 wasn't given to us, I know that log of 10 is exactly 1. So I get 1.9 when I combine. Okay, 64. Again, there's a few ways we could go about doing this. I could use subtraction, right? I could do, or I could use only subtraction, sorry. 64 is 8 times 8, which will become 2 logarithms. Or I can do 64 as 8 squared. So we'll go with the 8 squared method this time. And there's also a lot of ways I could rewrite, like I'm ignoring the 1 right now, but I could do 1 over 64 as 1 over 8 squared, or just 1 over 8 squared. Those are equivalent, so I'm going to choose to use this bottom one, so I don't have to worry about distributing a 2. So log of 1 over 8 squared. Now I'm kind of ignoring the fact that we haven't talked about log of 1, so let's add that to our list. I do know what log of 1 is. 10 to what power gives us 1? Well, that would be the 0 power. So log of 1 is 0. So this becomes log of 1 minus log of 8 squared. So that becomes log of 1 minus 2 log of 8. So I get log of 1 is 0 minus 2 times log of 8 is 0.9 or 0.9. I'm going to just make my writing a little smaller here so I can fit it all in one line. So this comes out to be, 0 minus 2 times 0.9, 2 times 9 is 18, so negative 1.8. Okay, there we have it. There's a few ways you could have gone about that one. So if you ended up doing log of 1 minus log of 8 minus log of 8, you should still get that same end result. I won't show both methods for this, but just know that you can do that. Okay, for starting at problem 9, we have new givens here. It gives us that log base 3 of 2 is 0.6, and log base 3 of 5 is about 1.5. Now we also know powers of 3. We don't need them for this 16, so we'll write those out if we need them. But 16, 5 isn't a factor there, but I could do 2 to the 4th power. And if you don't know 2 to the 4th right off the top of your head, just keep breaking it down. 2 times 8, 2 times 4, 2 times 2. I see I have 1, 2, 3, 4. 4 2's there, so 2 to the 4th power. So I'm going to use exponents for this one. I'm going to use the power property. So log base 3 of 2 to the 4th power. Well, that can be 4 times log base 3 of 2. And we know that log base 3 of 2 is approximately 0.6. So 4 times 6 is 24. So 4 times 0.6 is 2.4. Again, you could have actually done log base 3 of 2 plus log base 3 of 2 plus log base 3 of 2 plus log base 3 of 2, but it's just so much more writing, right? Because that's 0.6 plus 0.6 plus 0.6 plus 0.6. So is that 4 of them? 1, 2, 3, 4. Yeah. So we still get 2.4 as the result, but I think using powers is a little bit faster. So there's question 9. Now question 10, I copied down our givens again because we are going to use the same givens. But this time, 108, we can't get there with using only 2 and 5s. And remember, we don't want to be using our calculator for these. So we also want to be really thinking of how we can use 3s. So log base 3 of 3. So 3 to what power gives us 3? 3 to the first power. So log base 3 of 3 is 1, right? When I do this one, 3 squared is 9. So log base 3 of 9 is 2. 3 cubed is 27. So log base 3 of 27 is 3, and so on. I could keep listing. I went out to 81 because I feel like that's pretty good. Like I can do 3 times 3 is 9 times 3 times 3, right? 81. Actually, let's talk about a nice way to get there. Because a lot of people do 3 times 3 is 9, and then try to multiply 3 by that 9 by 3 to get 27. But I think a much faster way is to do 9 times 9 to get that 81. So anyways, we have those powers. We're going to have to use them, right? 108, we can tell that's divisible by 3. If we add all the terms up, 1 plus 0 plus 8, it is 3. So we can tell it's divisible by 3. So let's divide 108 by 3. I'm going to use a little long division here. Goes into this. 3 goes into 108, or goes into 10 3 times. So we'll write 9. With 1 left over, carry down that 8, so 36. So that is 3 times 36. Well, maybe again we see that we can do a 3 times 12, and this becomes 3 times 4. So we're breaking down that 108. So let's kind of log base 3 of, I have 1, 2, 3 3s. So 3 cubed times, and this can be 2 times 2. Times 2 squared. So 27 times 4. And again, you could have done this a few different ways, but this is how I chose to do it using the properties. So this becomes log base 3 of 3 cubed plus log base 3 of 2 squared. So if I use the power product there, I can bring that 3 in front. Log base 3 of 3 plus 2 times log base 3 of 2. Well, log base 3 of 3, this is just 1. Plus 2 times 0.6. Okay, let me just create a little bit more space for us here. Okay. So, this leads us to 3 plus 1.2. 2 times 6 is 12, so 3 plus 1.2, we get 4.2 as our final answer. Again, I want that to fit on the page. I know it's a video, so we don't really need it to, but here we go. Okay, so there is log base 3 of 108. Okay. Let's look at our log base 3 of 3 over 50. So hopefully that 3 stands out to us right away. We can use that. So let's think about the 50. 50, remember we have 2s and 5s. So I know 2 times 5 gives us that 10. So if we multiply it by another 5, we get our 50. I'll use multiplication here as opposed to powers. So 3 over 2 times 5 times 5. I could absolutely write that as 5 squared, but since I've done a lot of power rules here, let's do multiplication in the denominator. So that becomes log base 3 of 3 minus, because it's in the denominator, log base 3 of 2 minus, remember everything in the denominator has that negative coefficient in front of it. And since I have 3 things in the denominator, I have 3 logarithms that have that negative sign in front. Negative log base 3 of 2, negative log base 3 of 5, negative log base 3 of 5 again. So, log base 3 of 3 is 1. Log base 3 of 2 is 0.6. Is that what we said, right? Yep. 0.6. And log base 3 of 5 is 1.5. So we're doing these without a calculator, so let's combine carefully. Right, 1 minus 0.6, that gives us 0.4. We'll write it out in steps, yeah. So that gives us 0.4. And then negative 1.5 minus 1.5 is negative 3. So 0.4 minus 1.5 minus 1.5, or minus 0.4 minus 3, is negative 2.6. Okay, I'm going to make sure that negative sign is super clear. I don't want to accidentally cut it off a little bit. So there we go. There's log of 3 over 50. Okay, so question 12. Log base 3 of 8 over 15. Always look to see if these simplify, by the way. This one doesn't, right? But 8 can be written as 2 cubed, and 15 is 3 times 5. So I'm, again, using 2s, 5s, and 3s. So log base 3 of 2 cubed, and I could do 2 times 2 times 2, but I'm going to do it as 2 cubed because I think that's a little faster. And then 3 times 5 on the bottom. That gives me, and I'll use a shortcut. I'm going to pull that 3 down in front in one step. So 3 log base 3, 2, minus log base 3 of 3, minus log base 3 of 5. Now that we've used that power rule a few times, I feel comfortable using a little shortcut and skipping one step, but by all means write it out as 2 steps. Right, this is coming from log base 3 of 2 cubed. So I have 3 times 0.6 minus, well, log base 3 of 3 is 1, minus 1.5. So 3 times 6 is 18, so I get 1.8 minus 1 minus 1.5. Right, so 1.8 minus 1.5, let's do those two first because that gives us a 0.3. And then 0.3 minus 1 gives us negative 0.7. All right, let me double check that mental math in my head by doing it in a different order. Just doesn't hurt to redo it in a different order. 1.8 minus 1 is 0.8, and then 0.8 minus 1.5, that has a difference of 7. So we get negative 0.7 both times, which is good. Never hurts to double check when we are not using a calculator. Okay. 486. So again, this is a big number, but we should expect to use 2s, 5s, and 3s. So 2 is a pretty quick one to see. We see it ends in an even number. So 486 divided by 2, that gives us 243. Right? 4 over 2 is 2. 8 over 2 is 4. 6 over 2 is 3. So now let's check for 3. So 243 is going to be divisible by 3. So let's start with 486. We know it's 2. So let's break down this 243. We can start by just dividing it by 3. 24 divided by 3 is 8. And then 3 divided by 3 is 1. So it becomes 81. And we recognize this as 9 times 9, or 3 times 3 times 3 times 3. So I have 1, 2, 3, 4, 5 3s. So if we know which numbers to check and test, it goes a little faster. So this becomes log base 3 of 2 times 3 to the 5th. So we get log base 3 of 2 plus log base 3 of 3 to the 5th. Okay, I'll zoom out a little so we can see that whole problem taking shape. So log base 3 of 2 is 0.6, and this becomes 5 times 1, right? I bring that 5 down in front, and log base 3 of 3 is 1. So really, we get 5.6. So for such a big number, it ended up being almost the fewest steps. Okay, 18. Again, look for those 2s and 3s. 18 is a 2. 2 times 9, which is 3 times 3. So I'll do this one without using exponents. Log base 3 of 2 times 3 times 3. So that gives me log base 3 of 2 plus log base 3 of 3. And then plus log base 3 of 3 again. Log base 3 of 2 is 0.6. And log base 3 of 3 is 1. So 0.6 plus 1 is 2.6. Okay. That was problem 14. All right, let's go to problem 15. So again, I see a 120. So quickly I can kind of see maybe where I'm getting a 2 there. It's an even number. So 120 divided by 2 is 60. So 60 is even again, right? 120 equals, so let's do 60 divided by 2 is 30. Again, that's even. 30 divided by 2 is 15. We finally get down to an odd number, but let's be careful we're not dropping how many 2's. So we did 1, 2, 3 times we divided by 2. So 2 cubed. Right? We can also think of it as dividing by 8 if we want to double check that. Let's divide by 8. Oop, not square root. Divide by 8. 8 goes in, so it goes in 1 time with 4 left over. Bring that down, and we do get 15. So our work checks. That's good. We're not using calculator. And 15 is 3 times 5. So log of 120 can be written at log base 3 of 120 can be rewritten as 2 cubed times 3 times 5. Okay, so that gives me, I'm going to again use that power property right away. 3 log base 3 of 2 plus log base 3 of 3 plus log base 3 of 5. And remember, this is from first doing log base 3 of 2 cubed. So that gives me 3 times 0.6 plus 1 plus 1.5. So 3 times 0.6 is 1.8 plus 1 plus 1.5. So let's see. 1 plus 1 plus 1, that's 3. 0.8 plus 0.5, it's 1.3. So 3 plus 1.3, we get 4.3. Okay, let's make that fit on a page nicely. There we go. And excuse me, I gotta pause while I plug in my computer. Okay, my computer is now charging and we can resume. So our last one on this page before we go to calculator work is log base 3 of 32 over 45. So again, let's break down this 32 and the 45. So 32, we might know that one off the top of our head. Excuse me, we're got a little misplaced there. There we go. But if you don't, that's okay. Break it down so it does become 2 to the. Well, before we get there, let's just do 2 to the 16 first, right? So we know 16 can be 2 times 2 times 8. Well, that's 2 times 2. Well, 8 is 2 cubed. So this is 2 to the 5th power. And again, if you recognize that off the top of your head, wonderful, but we don't need to recognize it off the top of our head. We can always break it down a little. So that's where our 32 is coming from. Let's kind of organize ourselves a little. This is all going to problem 15. So 45, well, that becomes 5 times 9, or 5 times 3 squared if we want to use some powers here. So this becomes log base 3 of 2 to the 5th over 5 times 3 squared. So, again, we have, I'll show all the steps for this one. Log base 3 of 2 to the 5th. Since they're in the denominator, we do minus log base 3 of 5 minus log base 3 of 3 squared. Okay, so let's use our power rule now to bring those exponents down, which we don't always have to do. But for this one, we want to do that. There's no exponent on log base 3 of 5. This one, we really don't need to bring that down. I could actually use a different shortcut where if those bases match, it's always going to be what the exponent is. But for the sake of practicing this power rule, let's bring it down. So 2 times log base 3 of 3. Okay, so we end up with 5 times 0.6 minus 1.5 minus 2 times 1, right? Log base 3 of 3 is 1. So I guess I'll work downward here. This gives us 3. 5 times 6 is 30, so 5 times 0.6 is 3. Minus 1.5 minus 2 is negative 3.5. So that totals negative 0. Oh, gosh, negative 0.5. Awesome. So there's question 16. Let me just get this onto one page. All right, let's go down to questions 17, 18, and 19, the last 3 on this page for my layout. So, question 17. This one says this is the go section. So use your calculator and the definition of log x to find the value of x. Round your answers to 4 decimals. So, definition of log x. This is our common log. Common log means we don't see a base written. So, log x is the same thing as log base 10 of x, right? So, when we have that, and I'll write it out as an equation, right? If I write it as y equals log of x in exponential form, this can become 10 to the y equals x. The input of the logarithm becomes the output of the exponential, and the output of the logarithm becomes the input of the exponential. So that input and output are sort of reversing. So we actually don't need our calculator for many of these. We can do these in our head. If I write it in exponential form first, I have 10 to the negative 3 equals x. Well, 10 to the negative 3 is the same thing as 1 over 10 cubed. And I know 10 cubed is 1,000. So this becomes 1 over 1,000 to the x. Or, I'll write my final answer on the line below. 0.123. So 0.001. Now it does say round to 4 decimal places, so just to follow directions, I'll throw another 0 at the end there. You can always add zeros at the end. Okay, so there is our first one. So 18. We're going to rewrite this as 10 to the first power equals x. And again, there's not much algebraic work to do there. 10 to the first power is 10. So our answer is just x equals 10. If we want to put those 4 decimal places, we just go ahead and add 0.0000. Here, 10 to the 0 power equals x. Well, anything raised to the 0 power with the exception of, 0 and infinity and some other negative infinities and stuff like that. But most numbers raised to the 0 power is just 1. So here we just get x equals 1. Again, if we want 4 decimal places, we just do 0.0000. There we go. So there's 19. Okay, so number 20. We actually do need our calculator for these ones because they're not nice integers. So let's rewrite it as 10 to the 1/2 power equals x. So this one, or the square root of 10 if you want to think of it that way, we know that we're getting smaller than 10. The square root of 9 is 3. So we're going to be something just above 3. It's good to sort of estimate these in your head a little bit to make sure you're typing in your calculator accurately. But we get 3.162. And then our next two decimal places are 2, 7. So that 2 is going to round up to a 3. So there's 10 to the 1/2, or log of x equals 1/2. So for this one, we're going to rewrite it as 10 to the 1.75 equals x. Well, we know 10 to the first is 10, and 10 squared is 100. So this should be something in between 10 and 100. So 10 raised to the 1.75 does give us something in between 10 and 100. It gives us 56.234. Now our next two decimal places are 1, 3. So I'm just going to keep it at 1. It does not round up. Okay, so this one becomes problem number 22. 10 to the negative 2.2 equals x. Since our exponent is negative, that's the same thing as saying 1 over 10 to 2.2. So we're going to get a number that's actually less than 1 here. Negative 2.2, and the exponent is going to give us that decimal answer. So 0.006. And the next two numbers are 3, 0, so 3 does not round up. So 0.063. Okay. Here, 10 to the 3.67 equals x, right? So 10 to the third is 1,000, and 10 to the fourth is 10,000. So we're going to get a number in between 1,000 and 10,000. So x equals roughly 4,677.351. And then the next two numbers are 4, 1, so the 4 does not round up. So 4,677.3514. Okay. 10 to the 3/4 equals x. So 3/4, that's less than 1. So we're going to get something that's less than 10. We're going to go downwards, right? So 10 raised to 3/4, or 0.75 if you prefer the decimal, is 5.62341. So since it's followed by 1, it does not round up, right? 10 to the 0 is 1, and 10 to the negative 1 is 0.1. So it makes sense that we get something 0.75. Oh wait, why am I doing negative 1? 10 to the 1 is 10. So 0.75 is in between 0 and 1. Makes sense that we get a number between 1 and 10. Excuse me. Okay, 25. This one we don't need our calculator because 6 is a nice integer. So 10 to the 6, that means we need 6 zeros. 1, 2, 3, 4, 5, 6, or a million. Now if I want 4 decimal places, I just plop that on the end. So that one we don't need our calculator. It's exactly 1 million. And that is it. So that was Unit 2, Lesson 4. Hopefully you found this video helpful, and thank you for watching.